So for this afternoon, we'll discuss critical points, maxima, and minima. So this is where we go to the applications of your differential calculus. So critical points, maxima, minima. I'm sure you've heard of these words. And then sometimes in some books, you will encounter the words extrema, or that's the plural form of extremum. So it means extreme points or extreme conditions. So let f be defined on an interval. So function f is defined on the interval I containing a constant c. So that means the function of c is the minimum of the function when the function c is less than or equal to the function of x at any other point. Whereas the function c is the maximum of f on the interval when you substitute c in f, it is greater than any other value. So the minimum and maximum of a function are the extreme values, or sometimes called extrema. There are what you call the absolute minimum and absolute maximum. Sometimes they are termed as the global minimum and global maximum. But sometimes if it's on the endpoints of the interval, they're called the endpoint extremum or endpoint extrema. So let's go to the definition of a relative extrema, because this one, it's just the definition of extreme point. A relative extrema, so if there is an open interval containing c, on which f of c is a maximum, then that is called a relative maximum. Whereas if there contains a point or its minimum, then it's called a relative minimum. So relative minimum and relative maximum are called local maximum or local minimum. So I know it's a bit too much to take in, but I'm sure you will be able to understand this as we go to the examples. For example, in here, you have the graph, the red graph of f of x. What happens is that I have in here 3 distinct points. There are actually a lot of points, but what I selected are 3 points. The 2 points above are maximum points because they are on top. Like, for example, it's a hill. On the hill, that's a maximum point, and then this is another maximum, whereas this one is a minimum point. So when you look at these two, the right side is much greater in terms of letter y compared to the left side. So among the two maxima values, this is what you call the global maximum, whereas the left side is called a local maximum. Since in here you only have one, you can just say that could be the local minimum. Okay, so for the right graph, look at this. In this, I did not include the endpoints. On this graph here at the right side, you can see here that the extreme point is being included in here. So since that extreme point is higher than the maximum in the graph, this one is just what you call a local maximum. That one is a global maximum, but then what kind? It's called an endpoint extremum. So an endpoint maximum, right? Do you remember this? Oh? Here, an endpoint extrema. So here, the global maximum is an endpoint. And then you have a global minimum here because there's another minimum in there. And if this is the end of the curve, you can say this is another maximum. So there are 3 maximum values. These 2 are local maxima. That one is the global maxima. Okay? So there are several points in this curve. I did not identify any other points. So just focusing on these points, can you give me the maximum values, guys? A, E, and H are the maximum values. That's correct. And then the minimum values are C, G, and J, right? Now, from among the maximum values, can you give me the global or absolute maximum? The absolute maximum is letter E. So that means any other maximum is just what? Local. What is the local, or what is the global minimum? Letter G. So in here, the absolute maximum is E. Relative, all of them are relative to each other, they're maximum. However, this one from among the relative maxima is the global maxima. So here, this is the absolute. So you can just say those two relatively are still minimum. Now, in between those graphs, there are still some points. Can you identify those points that are not maximum or minimum? What letters are they? B, D, F, and I. So, what are the B, D, F, and I? So, B, D, F, and I, those are points between the maximum and minimum, right? So, they are actually what you call the points of inflection. So, what's the point of inflection? They are points containing two different concavities or in between concavities. Kasi look, on the left side of B, it's concave down because it's opening down. On the right side of B, it's concave up because the graph is opening up. On the right side of D, it's concave down. And then on the right side of F, it's concave up. On the left side of I, it's concave down, and so on. So those are points of inflection. So let's go to the definition. The important thing about this one is that they are what you call maximum or minimum, especially when we deal with optimization. Those maximum and minimum are what you call critical points. Why? Why are they critical? And sometimes, points of inflection are also termed as critical points. But typically, when you say critical, they're the maximum and the minimum. So, for example, when you're doing some modeling, you can say, what should be the maximum amount of like, let's say, the manufacturing industry so that industry will not go broke. So, because sometimes you have to remember that when you do operation, even if you're producing a lot, sometimes it cannot parang you may not be able to produce a certain amount unless you hire more personnel or unless you buy more machineries. So what should be the maximum value so that you don't need to hire more personnel or you don't need to purchase new equipment? And sometimes you'll be asked, what is the minimum amount so that to break even? So it's minimum, it's a critical number. So going here, let's go to the critical points and the concavity. Concavity, it's a section of a curve which have tangent lines that has non-zero slopes. So look at this, the curve, pink curve. In the pink curve there, you can see there that there are certain tangent lines. So in this case, the tangent line, you know that the slope is positive. This one, the slope is also positive, but then which is bigger? Slope number 1 or slope number 2? Both are positive. You can see that slope 2 is bigger than slope 1, so that means it's increasing. The function is increasing. Whereas in this case, let's just say slope number 1, you know that that's negative. Slope number 2, that's also negative. Now, which is more negative? Slope number 2 is more negative, less than slope number 1. Therefore, it's decreasing. Okay, so this is basically the definition of increasing and decreasing function. So you'll notice here that a curve is considered to be concaving upwards if the slope of the tangent line is positive, and the concave downwards if the slope is negative. So what are points of inflection? Earlier, I mentioned to you that points of inflection is a point in which you can see changes in concavity. So let f be a function that is continuous on an open interval, and let c be a point in the interval. If the graph of f has a tangent line at this point, then this is what you call a point of inflection. So look at this. This is the point of inflection. If I ask you, guys, the left side is concave down, but then the right side, the blue one, is concave up. So between the concave up and the concave down, there should exist a point of inflection. So when there is a change in concavity, look here. In this case, look at the pink curve. On the left side of the green dot, you can say, oh, that's concave up. But then as you move, it becomes concave down. And here, it's concave down, and then it changed to concave upward. So again, between the changes, there should exist a point of inflection. Okay? Sometimes known as just PI. So we need to know how to identify the critical points. So what are the steps? First is determine the y prime, and then identify the value of x in which y prime is equal to 0. So technically, you're solving for the roots. Solve for x when y prime is 0, and then solve for the y of the roots. Now, these are critical points. I'll show this to you as we're solving later on. Now, you also need to solve for y double prime because there might exist some more points. And then we have to identify if these points are critical points, basically maxima or minima, or simply points of inflection. Okay? So how do we classify this? This is what you call, there's what you call the first derivative and second derivative tests. So you have to recall that this one, take note that this one is test of slopes. This one is what you call the test of concavities. So that means if y prime is positive, it's sloping up. If y prime is negative, it's sloping down. If y double prime is positive, it is smiling, or it's basically concave up. Its y double prime is negative, it's concave down. Okay? So, the first derivative test. Let's go back to this after we do the actual application. Here, you can see here that in the interval A to B, there exists a number C. If at the left side of the number C, the slope is negative, and then at the right side of number C, the slope is positive, that means there exists a minimum point at C. Whereas between A and B, the left side of C, it's positively sloped. The right side is negatively sloped. That means C is a maximum. Now, in here, you'll notice, guys, that you have C. The right side, the left side is positive. The right side is also positive. So that means the slopes are positive. Pero look at this. The left side of this, even if it's the slope is positive, it's concave down. The right side is concave up. So that means C is a point of inflection. So let's check here. The second derivative test, I'll show that to you. Basically here, the second derivative test, as I said, if the second derivative is greater than 0, it's concave up. So if it's concave up, that means point C is a minimum. In here, if the f double prime of C is less than 0, that means it's concave down. That point C there is a maximum. let's go to this graph. The graph of f of x is equal to negative 3x to the fifth plus 5x cubed. You can see it's a cubic 5 equation of degree 5. You can see here that at a certain point, it is a minimum point, relative minimum. At a certain point, there is a relative maximum here. And then in between them, there exists a point of inflection. Why is it a point of inflection and not just any point? Because at the right side and left side of it, it changes in concavity. Okay, so there are some examples. Find the critical point of the following and classify it using the first derivative test and the second derivative tests. So let's go to the first one. Basically, the first step should be solve for y prime and y double prime. That means my y prime is 12 minus 3x squared. So if you factor this, this becomes 3, 4 minus x squared, or 3, 2 plus x, 2 minus x. This is your y prime. Now, let's solve for y double prime, basing it from here. Negative 6x. Now, next step. Solve for the critical points. How do you solve for the critical points? Y prime is 0. Solve for x. Y double prime is 0. Solve for x. Okay, so let's go to the first one. 0 is equal to 3, 2 plus x, and 2 minus x. Therefore, x is either negative 2 or positive 2. Now, let's go to the other one. Y double prime though is 0. So 0 is equal to negative 6x. That means x is 0. So, if x is negative 2, what is y equal to? How do you get y? Look back on top, the original equation. What is y equal to? Can you solve? 2 minus 24 is negative 22 plus 8. Guys, what's negative 22 plus 8? Negative 14. What about this one? 2 plus 24 is 26 minus 8. Is that 18? Right? If x is 0, y is 2. So let's evaluate because we know that these are the points. The points are 218, negative 2, negative 14, 0, 2. All right. So these are the 3 points. Some of you might say, sir, it's obvious 218 is maximum, negative 2, negative 14 is minimum. Yes, it might be evident, but I would like proof. So how do you prove? Prove. So part number 1 is what you call the first derivative test. This is the test of slopes. So x equals negative 2, x equals 2, tsaka may isa pa, x equals 0. In the first derivative test, let's think of numbers to the left and right. Left of negative 2 is negative 3. Right side is negative 1. Left of this is 1 and then 3. Left is negative 1 and positive 1. Okay. So, guys, what is the y prime? So what we do here is we substitute -3 to the equation of y prime. This is actually, guys, the reason why I try factoring out. 2 plus 3 is 2 plus -3 is negative. 2 minus -3 is positive. So negative times positive is negative. Okay. Now, if it's exactly -2, -2 plus 2, that's 0. And then at -1, 2 plus -1 is positive. 2 minus -1, that's positive also. So, since this is a test of slopes, you can see that the shape of the curve, negative. If it's 0, it's flat, positive. Oh, you can see that here, maybe that's a minimum. Pero let's see later on as we go along. In here, if I plug in 1 in the y prime, 2 plus 1 is positive. 2 minus 1 is also positive. So positive times positive is plus. Where did -1 come from? It basically is, think of a number that's greater than and less than -2. So less than -2 is -3, greater than it is -1. At exactly 2, 2 plus 2 is 4. 2 minus 2 is 0. The slope is 0. And then if it's 3, 2 plus 3 is 5. 2 minus 3 is -1. So positive times negative is negative. That means it's positive, horizontal, negative. So it seems as if -2, -14 is your minima. Yeah. And 2, 18 is your maxima. Let's prove. How do you prove this? Basically, you prove this using the secondary or second derivative test. According to the second derivative test, all we need is the y double prime. What is the y double prime, guys, of -2? -6 times -2 is positive. So it's opening up, right? That means this one is a minima. Let's go to this. Y double prime of number 2. 2 plus, -6 times 2 is -12. So that means it's negative or basically frowning. Since it's frowning, it is a maxima. That means we were able to evaluate the 2. Let's evaluate the last one. X equals 0. So let's think of left and right, -1 and +1. Let's apply that to the y prime and y double prime. So for y prime, -1, 2 plus -1 is positive. 2 minus -1, it's still positive. So the slope is right. At x equals 0, 2 plus 0, 2 minus 0, it's still positive. So pag ganun. Now, if it's 1, 2 plus 1 is 3, 2 minus 1 is positive. So some of us will ask, Sir, paano yan? But all of the slopes are increasing. Let's see. You will ask me, what's the y double prime at 0? Don't get y double prime at 0 because that's actually where you get it from. Get the y double prime of -1. What's the y double prime of -1, guys? -6 times -1 is what? Diba positive? If it's +1, I just apply that to -6 times +1 is negative. So that means this is a point of inflection. So here, 218 maximum, minimum, and point of inflection. So if you want to graph this, so let's just say 18, negative 2, 14. So that means 218 will be a maximum point. All right. So you're basically just asked to identify naman eh. Let's try another one. Y double prime is 6x squared plus 7x. There's nothing anymore. So here, why 7x? 18x, sorry. Basically, it's 6x and x plus 3. Okay. So the y double prime is basically based from this 12x plus 18. So you can factor out 6. So that's 2x plus 3. So this is your step number 1. Step number 2, equate them to 0. So that means 0 is equal to 6x, x plus 3. And 0 is 6, 2x plus 3. So the answer is x either 0 or negative 3. The answer here is x is negative 3 over 2. Okay? So, you already solved for the x. But what we need to solve for is also the y. Why? Because it's a point. It has to have both x and y. So when x is 0, let's substitute it back on top. Okay, y is negative 13. If x is negative 3, guys, negative 3 cube is negative 27 times 2 is negative 54. Negative 54 minus 13 is negative 67. Negative 67 plus 81. What's the answer? 14. Okay. When x is 3 halves, can you solve for it? If it's negative 3 halves, 1 half. All right. So just by looking, 0, negative 13, you might say, that's a minimum. Negative 3, positive 14, that's a maximum. This one may be just a point of inflection. Let's see. So let's check 0, negative 13, negative 3, 14, and negative 3 halves, 1 half. All right. So in the test, there's again the first derivative test and the second derivative test. Again, guys, what is the first derivative test for? That's the test of slopes. So what we place here, guys, is the numbers first. So x equals 0, x equals negative 3. Let's do this first, the one from the y prime. So let's think of a number to the left side and to the right side of it. Think of a number to the left side and to the right side of it. Okay, and then since this is a first derivative, it's y prime. Let's plug in negative 1. Negative 1 plus 3 is positive 2. Kaya lang there's a negative outside, so it's negative. It's like that. If you plug in 0, it's automatically 0. If you plug in 1, 6 times 1 is positive 6. 1 plus 3 is positive 4. So both are positive. That means it's like this. Can you follow? All right. So if it's negative 4, 6 times negative 4 is negative. Negative 4 plus 3 is still negative. Both negatives give us a positive. If it's negative 3, so that's negative. Negative 3 plus 0, it becomes 0. So it's flat. If it's negative 2, 6 times negative 2, that's negative. Negative 2 plus 3, that's positive. So meaning it's like this. Guys, what can you assume? That 0 is what? Minimum or maximum? Yes, it's minimum. So let's go to the second derivative test. So second derivative test, let's plug in the actual value in the second derivative. If it's 0, 0 plus 3 is positive 3 times 6, it's positive. So it's just smiling. That means you have proven now that this one is minimum. All right. This one, let's try to check the second derivative. Y double prime of negative 3. Let's plug negative 3 in the y double prime equation. Negative 3 times 2 is negative 6 plus 3 is negative 3 times 6. That's negative, so it's concave down. So since it's concave down, I can say that this one is maximum. All right, let's go to the next point. X is negative 3 halves. So negative 3 halves is negative 1.5. Since it's negative 1.5, negative 2, and negative 1. As I said, let's just think of those values. First derivative test and second derivative test. Okay. Guys, let's plug in negative 2 in the first derivative. What will it give us, guys? When you plug in negative 2 in the first derivative, the slope. Yes, what type of slope? Positive or negatively sloped? Negative. So, like this. Now, if it's negative 1, negative 1 plus 3, that's positive 2. 6 times negative 1 is negative. So, negatively sloped ulit. So just by looking at this, we need to prove that there is change in concavity. Okay, let's go to the second derivative test. Okay, let's plug in negative 2 in the second derivative. 2 times negative 2 is negative 4, plus 3 is negative 1, times 6, negative. In here, the second derivative. Negative 2 times this is negative 4 plus 3, negative 1. So that means it's concave down. Hopefully, for negative 1, it's positive. 2 times negative 1 is negative 2 plus 3 is positive 1. So that means this is a point of inflection. Can you follow? So if I ask you, could you graph this? The other one is 0, positive 13. The other one is negative 13 pala. So something like that. Negative 1.5, negative 1 half. Guys, there's a point. If x is negative 3 daw, plug it in the original. The answer is 1, is it? So let's see. Negative 3 halves cube is negative 27 over 8. So it's negative 27 over 4. 81 over 4. 81 over 4, guys, minus 27 over 4. Can you plug in negative 1 half here for the excess? What's the answer for y? Diba 14 over 4? So that means this is the approximate shape of your curve. It's true that this one is your maximum. That one there. This is your minimum, and this one is your point of inflection. All right. I'll be answering this one. So this is worded problems. Determine A, B, C, and D so that the curve y is equal to ax cubed plus bx squared plus cx plus d will have a critical point at the origin and the point of inflection at 0.24. So, look at the keywords. Critical point at the origin. Okay. and point of inflection at 2, 4. So you're given the equation y is equal to a x cubed plus bx squared plus cx plus d. It has CP at 0, 0 and point of inflection at 2, 4. Okay, in order to do this, we have to be able to know what y prime and y double prime are. Take note that a, b, c, and d are constants. So that means this is 3ax squared plus 2bx plus c. And then the d becomes 0. If it's y double prime, it's 6ax plus 2b. The rest are 0. Can you follow? Okay. Now look at the conditions. It says there that CP at 0, 0. When do we get CP? Isn't it that critical point may be obtained when y prime is equal to 0? So that means using this, 0 is equal to 3a 0 plus 2b 0 plus c. It so happened that your c is equal to 0. Now, it also says that point of inflection at 2, 4. When does the point of inflection happen? When y double prime is equal to 0. So that means 0 is equal to 6a, the x is 2, plus 2b. So 12a plus 2b equals 0. So we can't solve yet. Let's just name this as equation number 1. Now, what else do we have? Kasi the only conditions given are 2. What we do is we use 0, 0 and 2, 4 as points. So if we use them as points, what happens is this. If it's 0, 0, it becomes 0, a x cubed plus b x squared plus c x plus d. So that means d is equal to 0. That's also solved. Now, 4 is equal to a 2 cubed plus b 2 squared plus c. So let's expound. That's 8a plus 4b plus 2c. Right? So what can we solve? We know that c is 0. We know that d is 0. So I'll write here d first. We know that this one is also 0. So if I were to simplify this, I can say that this is 2a plus b is equal to 1. Am I correct? If I were to simplify this, it's going to be 6a plus b is equal to 0. Okay, so let's combine the two. I can see that equation number 2 minus equation number 1. So 6 minus 2, 2a minus 6a is negative 4a. b minus b is 0. 1 minus 0 is 1. Therefore, a is 1/4. So let's plug in a in those terms that contain c and d to get b. Here. Pwede na pala. 6a plus b is equal to 0. b is what, guys? Negative. Am I correct? Negative 3/2. So the final answer would then be, therefore, the equation is y is equal to 1/4 x cubed minus 3/2 x. B pala is squared. And then c is 0, d is 0. So that means this one would be your final answer. Let's go to another problem. Determine A, B, C, and D so that the curve has passes at 1/4 and at P -1, 2. And that point is an inflectional point with inflectional tangent 3x plus y equals 1. Okay. So you have y is equal to ax cubed plus bx plus c x plus d. And then passes 1/4 and -1, 2. It says here, point of inflection, P -1, 2. Inflectional tangent, so with inflectional tangent of 3x plus y equals -1. Okay, let's get to that later. Let's do this first. That's 3ax squared plus 2bx plus c. This one is 6ax plus 2b. So it's always like this. So it says there it passes through those points. So that means using 0.14, this is 4a plus b plus c plus d. And then using the other point, -1, 2. So this is 2. Negative a plus b minus c plus d. Now, it says there that it's a PI. So point of inflection, -1, 2. When does the point of inflection happen? When y double prime is 0. So that means let's look at the y double prime equation, equate that to 0. And then use -1, 2. So negative 6a plus 2b, right? Okay, so let's just simplify this. I can say that b is simply 3a. Let's have this equation. Let's just call this equation number 1, 2, number 3. Now, where's the other one? It says there, point of inflection with inflectional tangent. So when you see tangent, that means there's a tangent line. Y is -3x minus 1. The slope of the tangent line is -3. So, point -1, 2 with y prime equals -3. Can you follow, guys, what I meant by this? It is a point, and then it is also an inflection. And then that point has an inflectional tangent of this. So, the y prime, kasi y prime to y prime is -3 of -1, 2. So, 3a minus 2b plus c. So you will notice here, guys, that there are actually 4 equations. Now, my next question, guys. Which equation has the most number of knowns? 1 and 2. Am I correct? In the next equation, number 4, there's no letter D. So maybe what we do here is elimination. First step, eliminate D. In order to do that, let's just say equation 1 minus equation 2. 4 minus 2 is 2. A minus -b is 2a. B minus b, cancel. C minus -2 2c. So ito plus 2c. And then d minus d. Can you follow, guys? So this one is basically 1 is a plus c. Now, we have eliminated d. So maybe in here, this one, it's only a and b. So maybe we can cancel out c. We can say, equation number 4, eliminate c. Equation number 4 minus equation 5. Negative 3 minus 1 is negative 4. 3a minus a is 2a. Negative 2b. C minus c cancels out. So this one, you can say that one. So let's just call this equation number 6. It so happened that we have an equation number 3 with also small unknowns. So combine them. Negative 2 is equal to a minus 3a. Negative 2 is negative 2a. A is 1. B, C, and D. So if A is 1, what is B? Am I correct that B is 3? Okay. Letter C. Is this correct? What is D? Can you solve for D? 0, is it? Or negative 2? 0. So that means if that's the case, I'm not sure. That means your answer would then be y is equal to x cubed plus 3x squared.